Okay everyone, this is part 2 of the chapter 10 sequence and series videos. And so I'm just going to start off with a couple problems. So for this, it says, for what values of x does the summation of x raised to the n power over n factorial from 1 to infinity converge? And when it's asking for what values, what that means is what it's asking for is the interval of convergence. The interval of convergence. And that's the x values for which this power series will converge. So to find where that occurs, I'm going to use the ratio test. And recall that the ratio test is the limit as n goes towards infinity of here is your power series to the n plus 1 power, all over your original power series u to the n. So now when I plug in u to the n plus 1, I'm going to get x raised to the n plus 1 all over n plus 1 factorial, and that will be over the original power series, x to the n over n factorial. So now I'm going to clean it up a little. So recall that when you have x raised to the n plus 1 power, that is the same as if you said x to the n times x to the 1 power, and that will be over n plus 1 times, and then remember when you have factorials that when you multiply the next term, it's 1 minus the initial term. So here it's going to be n plus 1 times n factorial, and you'll see in a second why I did that, just to help clean this up. So when you have x raised to the n over n factorial, I'm going to flip that to get rid of the division, so n factorial over x to the n. So now you can see why I did the n plus 1 times n factorial. It's really to clean this up. Oh, and don't forget, this is still the limit as n goes towards infinity, and that applies here as well. Don't want to forget that part. And here your x's cross it out. So what you're left with is the limit as n goes towards infinity of the absolute value of x over n plus 1. So remember that your limit is in n, so whatever n value, you're getting infinitely larger. So when you plug in infinity for n, or n for infinity, this x value is just some number. So it's some number x. So what you're going to get when you plug in infinity for n is some number over infinity. And what that is really just 0. And so because it is 0, that means that the limit as n goes towards infinity for this power series, so x to the n over n factorial, is gonna approach 0. And because 0 is less than 1, it converges, the power series converges for all x. When you do these ratio tests and to find the interval convergence, you want the absolute value of your x to be less than 1. because that will show you that it converges for the interval of convergence. Oh, I think I spelled that wrong. Wow, I'm sorry. I can't spell. Interval of oh, just didn't finish it. I'm all over the place. Excuse that. Okay, so your x has to be an absolute value of less than your radius, and in this case your radius is 1. So because for all values of n, 0 is less than 1, your interval of convergence is infinity to infinity because it went to 0. So that's your first problem. So now we're going to go ahead and hop to the next one. Okay, so for what x does the summation of, in parentheses, -1 raised to the n minus 1 power times x raised to the n minus 1 power all over n plus 1 going from 1 to infinity converge? So again, when it says what x, it wants your interval of convergence. Okay, and again, I'm going to use the ratio test to solve what x is going to give me my interval of convergence. So the limit as n goes towards infinity of, remember the ratio test is your power series plus raised to the n, wherever you see n, you're going to place n plus 1 all over your original power series. So for this series, we're going to get the absolute value of -1 to the, instead of n minus 1, we're going to put n plus 1 minus 1, and then x to the n plus 1 minus 1 also, all over n plus 1 plus 1, and this is all over -1 to the n minus 1 times x to the n minus 1 all over n plus 1. And because we have these absolute values here, our answer is always going to be positive. So we can ignore this -1 because we want the absolute value of 1. So no matter what n it is, we want this to always be positive. So we're going to cancel out the -1 because we want the positive value. So now the limit as n goes towards infinity of this becomes x raised to the n, because it's 1 minus 1, all over n plus 2 times, I'm going to flip this up, n plus 1 over x to the n, and then it's x raised to the n minus 1, which is the same as x to the n times x to the -1. I'm just splitting it up so then I can cross these out because it's being multiplied, so there's 1 on top, 1 on bottom, so I'm able to cross those out. And then this x is to the -1, so if we bring it back to the top, that will give us a positive 1 value. So then we have the limit as n goes towards infinity of the absolute value of x times n plus 1 all over n plus 2. Now if I plug in infinity here, I'm going to get infinity over infinity. So when I see infinity over infinity, I think L'Hopital. So infinity over infinity. So we're going to use L'Hopital rule to simplify this limit. And because we're in n, we're taking the derivative over here. So we're taking the derivative of n, and then the x, remember again, it's just some number x. So here you get x times the derivative of n plus 1, which is just 1, all over the derivative of n plus 2, which is also 1. So what you get here, because there's no more n's left, your limit is equal to the absolute value of x. And like we said on this first problem here, we want the absolute value of x, which is going to be less than your radius. So we want this to be less than our radius, and that's going to be our radius of convergence. And so for your radius of convergence, if your power series, so let's see, if power series converges when the absolute value of x is less than r, and diverges when the absolute value of x is greater than r, then r is going to be your radius of convergence. So because we want the interval for which it converges, that's kind of where this came from. I'm sorry, I kind of forgot to mention that before. So you're going to use this to find where it converges, and that'll give you your radius of convergence. I can't spell today. Sorry. Okay. So here for this problem, our radius is 1. So we want the absolute value of x that is less than 1. And we have to check our endpoints also, because if it converges, oh sorry, I don't know if you can see that. If it converges at the endpoints, then it will be less than or equal to or greater than, because this is the same as -1 is less than x is less than 1. And so if it converges at these points, it's going to be equal to, but we have to check that first. So when x is equal to 1, we have the series becomes 1/2 minus 1/3 plus 1/4 minus 1/5 plus ... and I'm getting these numbers just by plugging in these n values. So like when n equals 1, you get 1 minus 1 would be 0. So -1 to the 0 power is just 1. And same here, 1 minus 1, you get 0. So x raised to the 1 power is just 0. Or sorry, x raised to the 0 power is 1. And then 1 plus 1 is 2. So that's where that 1/2 is coming from. And then just by plugging in like 1, 2, 3, 4, that's where this power series is coming from down here. And what this series shows is that it is an alternating convergent series. So therefore at x equals 1 it is convergent. So x is less than or equal to 1 there. So now we want to check when x is equal to -1. And by plugging in -1 for x and then using n equals 1 and then 2 and 3, I get the series 1/2 plus 1/3 plus 1/4 plus 1/5, and so on and so forth, and just by plugging in more n's. And this series actually diverges. Therefore, it does not converge at -1, so it's not part of your interval of convergence. So this ends up being your answer, that it is -1 is less than x, which is less than or equal to 1. That is your interval of convergence.